Okay, so this time we're going to go through practice Practicum 5, and Eliana is going to step us through the problems that are available to us. The first problem is called
Office hours.
And she'll read through the details of what we have to do.
A professor wishes to study how students make use of office hours. She has records of when her students arrive and when they see her. Note: the lineup can get long around assignment time. Write a program to simulate the professor's office hours. The program should simulate each minute of an office hour, starting at 0 minutes.
So the first thing I like to do is kind of think about what we can expect from the output and then make a plan. We see that we have our input as receiving an integer denoting the number of students, then followed by that many lines where each line contains an integer t denoting the student's arrival time in minutes, followed by a single word string denoting the student's name. If we look down at examples, we see that makes sense. That's where our input is. We're receiving 4 students. This student is arriving at time 60. Bob is arriving at time 80. They each have, so this is just a single word string, which is great. I can use .next when I'm reading in that input. So that's just a clue to me as to how the input's coming in. Then I see this output, and sometimes I like to look at that just to get my head around what I'm expected to do. Here's my input. I see Alice arriving. She's able to see the professor right away, and then 15 minutes later, she leaves. So let's take a little bit of a look as to what the processing had. It says each minute of the simulation has 3 phases. The student arrives. If the student's arrival time is the current time, the student arrives and lines up in the hallway. The student leaves. If a student finishes talking to the professor, they leave. The next student, if the professor is not seeing a student and there is a student in the hallway, the professor sees that student. Each session lasts exactly 15 minutes. When there are no more students coming, no more students waiting, and no students seeing the professor, all office hours are done. These are the big pieces that we're going to capture in our processing. Then the output is a lot of what we saw down there. Each line is terminated by a new line. We see time, student name arrives, time, student name leaves, time, student name sees a professor, and that all happens. The few things that I like to look at, it does happen in the order described. So student arrives, student leaves, next student. If I look down at an example here, I see Carol arrives, Bob leaves, Carol sees a professor, can all happen at the same time. And so we'll want to make sure that when we handle this, we're going to deal with the student arriving, leaving, next student in that kind of order. So let's create a plan for what that would look like, and also the details of what we need to store within our student object. So our student objects have a name and an arrival time, and that's all we know of for now. So honestly, I might even go into my student object and just capture that. So I have a private integer arrival time. I have a private string name, and then I would need a constructor for that, and it would be given the name student, and I would expect an integer arrival time, and I would expect a string name. And what I would do within that constructor method to construct a student, I would take whatever I'm given for arrival time, and I would set that equal to what is passed to the constructor method, and I would do the same with name. There we go. And then I would likely need to get these back. So I would create a getter. And I don't believe I need setters. I think I'll construct a student and then I'll just grab those arrival times and names. So for right now, I just need a way to get the arrival time back. And that takes no input. And I'm just going to return the arrival time associated with this student. And I want to do the same. I want to create a getter for name. So I'm going to return a string. It's going to be get name, and we're going to return this dot name. Now, if you were just using IntelliJ for this, you can use Command N, I think Control N on a PC, and you can generate the getter. But because we're pretending that we're writing this as a practical exam, then we will go ahead and type everything in. Okay, so now we need to translate everything from here over into what we want to do. So we have student arrives, student leaves, next student. I think I'm going to create a 0 for us. So I'm just going to put in here my notes. This is how I like to craft what I'm doing. I put in some comments first. So first I need to read in the input. So we have to read in the input. The next one, we are going to have student arrives. Actually, we're going to read in the input, and then we're going to step through time. I mean, that's a big thing. We're going to start from time 0, and we're going to step through time until as long as we still have meetings to come, until there's no more meetings. Okay, so that's something. Then within that, when we step through time, that's when all these other pieces happen. And actually, because those are the important pieces, I'm just going to, I think I'm going to have sub-steps. So I'm going to step through time. And when we step through time, there's a few things that are happen. Either a student arrives. The next piece was a student leaves. And then we have a next student. So student leaves. And 3 is next student. We're going to step through all of that. And we need ways to capture all of that. So we have a student object. And the other pieces that we're going to need is, so we have a student. We're also going to have a hallway that the students are going to line up. So we're going to have a hallway lineup. We will have to keep track of. Oh, sorry, we have a student objects, but then we also have the students to arrive. Left to arrive or something like that. We can call it whatever we want. The students left to arrive. We have the hallway lineup, and I will probably just call it hallway lineup like that, so I can keep track of it. And then we have the student in the meeting. So that, and we can think about what those are going to be. And then we also have to keep track of our meeting end time, whatever that is. Okay, so remember, students have an arrival time associated with them, and they have a name. Okay, so the students left to arrive. For me, this is going to be, I would think that this will be a linked list. They're going to arrive in a certain order, and they are going to be a linked list of type student. And the hallway lineup is, again, that there's an order to that. There's a first and there's a last. And this is also going to be a linked list of type student. This is a bunch of students in the hallway that we're going to deal with. And we have a student in meeting. That's going to be of type student. And the meeting end time is an integer. Okay. So the other thing that we have to keep track of is this notion of no more meetings. So in my mind, I also am going to have something that's just no more meetings, and I want that to be a Boolean. this is what I'm thinking I need to kind of make use, like, how do I deal with all of this? These are the pieces of my puzzle. And if I think about no more meetings, there's a few pieces there that I'm going to have to deal with. And that is like, how do I know when there's no more meetings? We'll come to that in a bit. Maybe that's 4 for me. Check if there are any more meetings. We want to update no more meetings. So we're going to update that Boolean variable. And so if I think through what that looks like to me, so we're going to step through all of this. So first we're going to read in the input, and that's pretty straightforward, right? That's just going to be populate the students left to arrive. Copy and paste that. The students left to arrive linked list. Okay, that's the plan for that. We're going to create a bunch of new students. Then we're going to step through time until there's no more meetings. And so I guess we could drop down here and think about, like, well, what does that even mean? And maybe there's provided there are any students. That's kind of an important piece. So we'll have to first, like, check that there are any students, and then after that, if there are any students, we're going to go ahead and go through that. So if we check that there are no more meetings, and we're going to update that no more meetings Boolean value, we'd have to decide what that means. Well, there are no more meetings if the following hold, right? So there are no more meetings if the students left, there are no more students to arrive. So that is, what did we call it? Students left to arrive. Students left to arrive. I'm going to put that down below. So if students left to arrive, that's a linked list. If that's empty, in my mind. Okay. And then the other thing that would have to be true, and so if all are true, there is no one waiting in the hall. So we call that, I don't know why I made it capital there, but I will change that. If there's no one waiting in the hall. And so we called that the hallway lineup. So that's a linked list. So if the hallway lineup is empty. Okay. And then finally, we also need to check that there is no one meeting. So there's 2 ways to, there is no one currently meeting. I'm planning to store the student that's meeting, so we could say that's null, or we could just use the meeting end time. It's an integer, so I kind of think if the meeting time is greater than current time, there's still somebody meeting. That's the way I kind of envision dealing with that. So that's the first piece, or that's our way that we're going to check through this. So, I mean, functionally, maybe we should just get this piece set up. So I'm going to just copy and paste a few things. I'm going to move this. This is what we need here. So let's just grab each of those. We're going to create, we created the student exists. So then we need a linked list of type student. I've already created that, so that's good. We're going to call it students left to arrive. We'll just get these things created. And we're going to say that's a new linked list. Great. And I'm going to copy and paste because I know I have another linked list of type student called hallway lineup. And then I also said that I'm going to have a student, which is my student in meeting, just so I can get their details. And that's null for now. We don't have anybody in the meeting. These are empty linked lists. There's no one to arrive yet. The hallway lineup is empty. All good for right now. And then we have the meeting end time, and we say that's an integer meeting end time, and time is going to start at 0. The meeting's done. Like, there's no meeting happening yet, so I'm going to set the meeting end time to -1, just so there's no expectation that there's somebody in the meeting. Okay. The next thing I say we have is a Boolean value that I'm planning to use, no more meetings. And that's great. I'm going to set that up to false to begin with, but we're going to have to decide, what does that actually mean? So it says, I decided that I would step through time until there's no more meetings, provided there are any students. So there would be no more meetings immediately if the students left to arrive started off empty. And so there's no more meetings if the students left to arrive is empty. Okay, so that looks like right now that's already true, and it would be if we didn't populate the details of the students to arrive. Okay, so this is why in this moment we have to read in the input, and I'll just go ahead and I'm going to leave those below. So we want to read in the input, and in fact we're going to do this check of whether or not there are any more meetings after that fact, right? That doesn't make sense to check until we've read in the students to arrive. And so we know that so we need a scanner, first of all. I have at the top already given to me java.util.scanner and java.util.linkedList. And so I can use a scanner, new scanner, system.in. And now I want to read in those details. So the first thing I get is the number of students. I was told that we get the number of students, so we can read in that next integer. And then we need a loop. We're going to run from I = 0. We're going to go through that number of students. So I less than number of students, I plus plus. So this is me looping from 0 to number of students -1. I'm going to run through this loop exactly number of students times, and I'm going to read in the details. So the first thing I get is their arrival time, and that's going to come in as an integer. Like if we remember, if we go back, we can look at that sample input. We first got the number of students, and then we got their arrival time and their name. And their name is a single word string. So what that means is I can read in their name as in.next, which is handy, and then not worry about clearing the line. I can go ahead and do that. And then every time I do that, what I want to do is create a new student. And in doing so, so I'm creating a student S. It's equal to a new student. And I'm passing in that arrival time and the name. And then what I want to do is add that student, that new student, to my linked list of students left to arrive. And they're coming in order, which is why I have a linked list, students left to arrive dot add S. Okay, so now I've added a student. It started off as an empty linked list, and now it has a first element. Okay. So now that's populated. And so at that point, it's provided I pass any students, then this runs, right? This is set. This is not empty. So this is set to false, meaning there are more meetings as long as there's a student. Okay, so now I'm going to do something. I'm just going to get my loop. Step through time until there are no more meetings. Okay, well, what does that mean? I'm going to deal with the few pieces that we've kind of already populated. And that is, I am going to pull this out. Okay, so step through time until there are no more meetings. What that means is I want to create something like a while loop, while until there are no more meetings. So as soon as I said until, I'm going to put an asterisk around that. I need a not. So the while, as long as there are not no more meetings, and we could have done that differently, certainly, but that's what I did, so I'm sticking to it. And I just did that because it was easier for me to think about what it means to have no more meetings. And so this Boolean value here is why I did it. So I'm going to just put these as single comments, and we're going to fill those details later. What it means to take in the next student and all those details we're going to figure out over time. But this last piece, check if there are any more meetings, and then update. We need to do that for this loop to work, right? So what that means is we're going to check. We're going to say no more meetings, and there are no more meetings if all of the following are true, and all of the following must be true means we're going to have a bunch of ands. Okay, so we have three things: this and this and that, and we'll figure out what those are. Okay, so I'm going to put my semicolon here, so at least it's happy with that. So there are no more meetings. The first thing is if there are no more students to arrive, and we said that's the same as students left to arrive is empty. Okay, so that's the first piece. And there is no one waiting in the hall. The hallway lineup is empty. And the meeting time is greater than time. Okay. Oh, but we don't have a time yet. So the question I would have then is, I said step through time, which I didn't create. So up here, instead, I could have had, I'm going to change this, and I still am going to check that there are no more meetings. But this time I'm going to go through time, and I'm going to just call it time. I have it as time down there. Time, we're going to start from time equals 0, and we're going to keep going until there are no more meetings. So as long as we haven't run out of meetings, we're going to keep going, and we're going to let time move forward. Okay, so now what this means is as we go through this loop, we're letting time be 0, and then 1, then 2, 3, 4, as long as we don't reach the end. And the end is reached when there are no more meetings. Which means that the condition we check to stay in here is that we haven't run out of meetings, that there's not no more meetings to be had. You could maybe come up with a better name for that Boolean value. So I have meeting time is greater than time. Do I have a meeting time? I haven't seem to have not created that yet. Oh, meeting end time. End time is greater than time. So we had called it something else. Meeting end time is greater than time. Okay, so that's all fine. But now we need to put in the details. So we have the students to arrive, we've got the student leaves, and we've got the next student, and they're not doing anything yet. So what does it mean if a student arrives? So if we look back here, we can see what that said. It says, if the next student's arrival time is the current time, the student arrives and lines up in the hallway. Okay, I'm going to copy that. We'll come back here. So it says, if the student's arrival time is the current time, the student arrives and lines up in the hallway. Okay, so if I want to get the next student's arrival time, first of all, I have to get the next student. To do that, what I want to do is get that first member of the student, what's it called? The students left to arrive linked list. Okay, so there's a big piece here. First of all, we need that student. And we can, student S is equal to student left to arrive dot peak. So I can get that first student. And what I can say is if S dot, and I guess there's a few pieces here. If the linked list were empty, then this could be null. So first of all, I should check if it's not equal to null. Then, and, oops, it's really not happy with me. And S dot get arrival time is, if that's equal to the current time, that means that they're arriving right now. Okay, so there's a few things that I think we need to do. First, we need to system.out.println, and we need to output those details. So first, we need to output their arrival time. What's equal to time, I can just use time, plus it was a colon, and then we need their name, plus S dot, we can get name. Did we not write a get name method for the student? Okay, what did I do here? Why is that not working? Check what I did in the student class. Aha! So it can't see it. It doesn't show up because I made it private, and this is a public getter, so it should have been made public. So I couldn't see it because it is not seeable. And the red goes away. So we want to say that they arrives, semicolon. Okay, so the first thing we want to do is let them arrive. They've arrived. We're going to output that. But then we also need to, they've arrived, so we need to remove that student from our students left to arrive linked list. So we're going to remove that student. Actually, first, before we remove them, the order almost doesn't matter. First, we want to add them to our hallway lineup. So we're going to add them, add that student S to the hallway lineup, and we're going to remove them from the students left to arrive. They've arrived. Now, it is possible that they could go straight into the office, but we first queue up in the hallway, and then we're going to move into the office. So it says, that is what it says. If the student's arrival time is the current time, the student arrives and lines up in the hallway. So they're no longer left to arrive because they've arrived. We remove them from that list, but we add them to the hallway lineup. Okay, so all good. And yeah, and so now we have to check if a student is leaving. And the way that we decide that is based on that meeting time. So we have a meeting end time. Sorry, I keep forgetting that I have it called end time. So if the end time is now, if meeting end time is equal to time, then a student is leaving. And because of the way we're going to set things up, then we should be able to pull up, we're going to output, so we're going to system.out.println the fact that they're leaving. And the way that we've stored that student is, in what case do we have it? What do we call it? Student in meeting. Student in meeting dot, oh no, we just need the time. First, we just need the time, plus colon. Now we need their name. So plus student meeting dot get name, which we can now see, which is good. And plus, oops, we'll put it here first and then pull it down. Plus, we're going to say leaves. Okay, so that's us saying that they've left, but we also have to allow them to leave. And so we need to say that student in meeting, we're going to set that to null, right? Because there should be no student there anymore. And we leave the meeting end time the same. That's okay. But then we have to pull in that next student. So if there's space available, we're going to let that next student arrive. So if we look back, let's just make sure we said if a student finishes talking to the professor, they leave. That's the big piece that we did here. So if a student finishes speaking to the professor, they leave. The next student, we're told if the professor is not seeing a student, then something happens. So let's capture that. I'll pull it around so that we can see it all in one space. So it says, if the professor is not seeing a student and there is a student in the hallway, the professor sees the student. Each session lasts exactly 15 minutes. Okay, so this works. So what does that mean if the professor is not seeing a student? Well, we know that that means that the meeting end time is less than or equal to the current time. So either someone just left or they left a while ago. But if there's space, so if the meeting end time is less than or equal to time, then they're not seeing a student. Okay. And so what we want to do is allow them to see a student. So there's a student in the hallway. Oh, so if the meeting end time is less than or equal to time and there's a student in the hallway. So we need to also check that the hallway lineup is not empty. So what you'll see is I put a not, and then I check that hallway lineup, which is our linked list, is not. We check the dot is empty, but I want to say it's not empty, and so I put the not in front of it. Okay, so if it's not empty and the meeting time is less than or equal to time, we're going to grab somebody from that hallway. So the way that we're going to grab that first individual is we're going to say, actually we're going to set them equal to the student in meeting is equal to the hallway lineup dot peak. So we're going to grab that first individual and we're going to set them equal to that student in meeting. We're going to set the new meeting end time to be exactly time plus 15 minutes because that's what we were told. Each session lasts exactly 15 minutes. And then we're going to, they're in the meeting now, and so we have to remove them from the hallway. So the hallway lineup, we're going to remove the student in the meeting. Whoever we pulled out, we're going to also remove. And then we did the check. I mean, we could have all sorts of problems built into this, but we can certainly give it a try. Oh, we didn't output anything here. So everywhere else we've kind of outputted our details. I'm going to go ahead and copy and paste this because it's very much similar to that format. So here we go, time, and then we want student meeting.get name, and then C's professor. I think it's what it's said to do. C's professor. Yeah. Okay. So we can copy our input. We can run it and see what happens. We could have all sorts of fun. But, oh, I think we didn't have any compilation errors, so that's good. So Alice arrives. Alice sees the professor. 15 minutes later, Alice leaves. At time 80, Bob arrives. Because Alice has already left, Bob sees the professor. And then exactly 15 minutes later, so at the same time Bob's going to leave, Carol arrives. Bob leaves. Carol sees the professor. In that time of overlap, Dave arrives, but can't see the professor. He goes into the hallway. Carol arrives at 1:10, and Dave sees the professor. Ooh, something fun I just realized. And Dave never left. So there is something missing from my check. That's so just to be clear, what I noticed was Dave sees the professor, but we didn't wait until he left. And so we're missing one piece there that we have to clean up. And I assume that is something doing with the no more meetings. Oh, right. So I have this wrong. So I have meeting time is greater than time. It really has to be, there's no more meetings if the meeting ended now. So I have it backwards. So I think this will maybe fix things. Let's go grab that input again. And so we'll see. I think that was what I was missing there. Little details matter. There we go. Okay, so now I'm content that we've got problem 1 solved, which is great. We will step on to problem 2 after you.